My name is Layla Cozart-Amos. I'm a first-year biology pre-med major, leadership studies minor from Charles County, Maryland.
My name is Jessica Johnson. I'm a first-year biology major on the cellular and molecular track, leadership studies and Spanish double minor from Bowie, Maryland.
My name is Jordan Robinson. I'm a first-year pharmaceutical science major, and I'm from Albany, New York.
Hello, everyone. My name is Brooke Varner. I'm a first-year psychology pre-medicine major from Bowie, Maryland.
Hi, my name is Tanal Walker. I'm a first-year biology pre-med major from Los Angeles, California. And this is our research poster focused on the migration of hawk species at Bethany Hawkwatch in correlation to temporal variation.
So to start off for introduction, the seasonal movement from one location to another, in this example, birds of prey, is known as migration. We focus on migration to see where and when animals relocate. These creatures, so specifically birds, might move to a variety of locations, but we're interested in why they choose to migrate where they did. The purpose of our research is to analyze temporal variation over the fall season. We analyzed the data from September to November from Bethany Hawkwatch in Mankato, Minnesota. Our objective is to find the temporal variations throughout the seasons to infer the highest migration months for birds of prey.
Our research question is, what are the contributions of temporal variation in hawks and hawk migration? And we're focusing on the months September through November.
So for the null hypothesis, and prediction, so we'll start off with the null hypothesis. Our null hypothesis was hawk migration will remain the same through September and November. Our hypothesis is hawk migration will be the highest in the early September fall season. And our prediction is hawk migration will decline during the winter seasons.
Our methods are birds of prey, specifically focusing on hawks, were migrating at during different months. We hypothesize that birds of prey migration will be highest during early September. We recorded the data from the fall 2020 season on the hawk count site, and we manipulated the data to study the different relations between temporal variations for the turkey vulture. We created graph charts and tables to represent the data we collected. This also helped us with organizing the data. And finally, we conducted that temporal variation impacted migration for the turkey vulture.
For the results, we found out that the 2020 data had the highest amount recorded. And in September, it had the highest abundance and richness with the amount of species of 5,977, an abundance of 16, a richness of 1.3, and in the yellow column 1.3, and the bright blue column 0.609, and in the brown column 0.468, and in the bright blue column, the bright green column 0.038. Also in November, we had the lowest abundance richness in 2020, and that was the amount of species that we had was 953. The abundance was 10. The richness was 1.32. In the yellow column, we had 0.06. In the bright blue column, we had 0.183. In the brown column, we had 0.193, and then in the green column, we had 0.0064. And that was for the table one. Figure one, we noticed that for both 2020 and 2021, September had the highest frequency.
As previously stated by Jordan, most of our data and results that are displayed here are from 2020. This is due to the fact that 2021 did not provide us with enough information for our research. Figure 2 is a scatter plot graph, which shows the correlations analysis of average daily temperature and bird of prey abundance. As you can see, as temperature decreases, the species abundance increases. There's a similar trend seen in figure 3, which is also a scatter plot. Figure 3 is the correlation analysis of average daily temperature, but this time versus bird of prey richness. This scatter plot graph shows that when daily samples increase, the daily species richness also increases. Overall, as abundance increase, richness increase, and evenness decrease.
We concluded that the contributions of temporal variation impacted migrating for hawks and hawk migration. All of the species were not seen and accounted for until August 15th in both 2020 and 2021, and our hypothesis was accepted. There is a positive correlation between abundance and species richness. The positive correlation between abundance and species richness gives evidence, or is seen in figure 2 and figure 3 gives evidence that temperature influences migration. In the state of Minnesota, their weather shifts between the months of October and November, giving evidence to why species abundance and richness may decline in these months. September in Minnesota is known to be one of the highest temperature months of autumn, along with August, having temperatures from 70 degrees Fahrenheit to 42 degrees Fahrenheit, while November is the lowest temperature month, with nights dropping below freezing. We concluded that species richness in Bethany Hawkwatch was its highest in early fall, which is September, and September and October of both years have the highest birds richness. And we acknowledge and give great gratitude to Dr. Sean Dash of the Biological Science Department of Hampton University for his resources and support for completion of the project, as well as NSF for funding the materials needed and supporting us during our research. We acknowledge Bethany Hawkwatch, Hawksite for providing sample data.